I got them all graded. I got them all graded. I just haven't posted it on what do y'all do Blackboard, right? Yeah, I haven't posted on Blackboard yet, but it is posted in Hawks. All right, so we're going to start off with addition, subtraction, and multiplication with radicals. Remember, radicals are just little square root symbols. Well, your opinion might change after today because that was the easy stuff Monday. So now what's going to happen is you're going to see things like this, and this does look complicated. But what we're going to do is we're going to treat these as two separate problems first, and we're going to simplify them first before actually adding them. The issue is for you to be able to add radicals, they have to have the same index. So it has to be a square root with a square root or a cube root with a cube root. And the radicand or the stuff inside that square root also has to be the same. Because when you're adding, you're really just combining like terms. So that's what adding and subtracting basically is. So before we can do that, obviously these two things don't look the same. Doesn't mean they won't become the same, but they currently do not look the same. So what we're going to do is we're going to use the little factor tree that we learned last Monday to help break this down. So what two numbers give me 75? 3 and 25. Good. There's 3 quarters and 75 cents. What does 25 break into? 5 and 5. How many numbers do I have to group up? 2. So I can group up these two fives. That will come out of the house. I have a leftover 3. Can I do anything with the A? No, because there's the imaginary 1 there, and then I'd have to divide by 2, and 2 doesn't even go into 1. So in that situation, I can't do anything with that A. So that A would also be a leftover. So I have my 5 that came out of the square root, and then I have the square root of 3A. Still recall this from Monday? Okay, perfect. And then I'll bring the plus sign down, and now we're going to do the same thing to the 48. What two things multiply to 48? I'm going to try that again. 74? 6 and 8 would be good. That's one. I think you're trying to think 24, but I don't know what number you typed in to get a 74. 48 by 2? Oh, 148. Okay, that's just it's just 48. I was like 24 would have been the answer, but then when you said 74, I was like, where's the 7 coming from? That's what I was trying to. That makes more sense. So you're right. That's it. So you got the 2 and 24 or 6 and 8. Both of those are appropriate numbers. Doesn't really matter. At the end of the day, we'll all end up with the same prime factorization. What will 6 break into? 3 and 2. Very good. 8 would break into 4 and 2. And then 4 would break into 2 and 2. What can I group up? I can group up 2 2s and another 2 2s. So if I have multiple things that I can group up, what am I going to do with them? Not add. If I have multiple things, I'm going to multiply. So 2 times 2 would give me 4. Now, I do know that realize that 2 plus 2 is also 4, but I do want you to know this is multiplication, not addition, because if it had been 2 and 3, the answer would be 6, not 5. And then I have a 3 that's left over, and then we just talked about the A not being able to do anything with that, so that ends up being the square root of 3A. So usually what happens, and I'm not going to say this happens every time because I've seen your homework, but what usually happens is these guys ends up being the same thing. So all you actually have to do is just do the stuff on the outside. So what is 5 plus 4? 9. And just like when we had fractions, the denominator always stay the same. In this case, the radical will always stay the same. So it will stay the square root of 3a. It does not become 6a or 6a squared or anything like that. The radical will stay the same. I just have to do whatever the operation. Uh-huh. Yep. So I was able to make two sets. Because it has to be two in a set. So I was able to make one group of two and a second group of two. So for every group I'm able to make, I need to multiply each group. So this becomes 1, 2. This becomes 1, 2. So then 2 times 2 is what gave me 4. Let's break it down like this. Let's take square root of 36. We know the answer is 6, correct? So what we'll do is we'll take 36, we'll break it down into 6 and 6, and this will be 2 and 3, and we'll just say 3 and 2 just because I want things to line up. I have a group of 3s and a group of 2s. Each group would make a number. So this group of 2 would make a 2, this group of 3 would make a 3, and I would multiply those. So this become 2 times 3, which is 6. So what's going on right here is I have a group of 2 times another group of 2, which would then give me the 4 that goes there. So for every group, it becomes one number, but then multiple groups, I need to multiply them. It does. That's fun. It's like one of those Angry Bird piggies. Yeah. All right. I used to make that joke when cell phones stuff out kids. I'd be like, I'm sorry, I'm not as entertaining as Angry Birds. But kids don't know what that is anymore. Apparently that's outdated. And I was like, man, I remember when Angry Birds like came out. I was like, gosh, this is the game. All right, but that's all you would have to do. So it's like you're simplifying two radical questions in one and then just combining like terms. Let's try another one. Square root of 45 plus square root of 20 plus square root of 27. Good. So we need to simplify each one of these just like we did up here. So what two things multiply? Oh, and by the way, this is where your calculator comes into handy because if you had typed the square root of 75, it would have came out 5 squared to 3. You just have to note to put the a back in there. And same concept with these things. So 45, what two numbers multiply 45? 9 and 5. What two things multiply 9? 3 and 3. What can I group up? So that becomes 1, 3 with a leftover of a 5. Ooh. And then we're going to do the same thing with the 20. Two things that multiply to 20. What two things multiply to 4? 2 and 2. I'm going to bring that plus sign down because that's part of the operation. But then what can I group up? 2's. Then it becomes 1, 2. And I have a leftover of 5. What does 27 break into? 9, very good. And then 9 breaks down into 3 and 3. What can I group up? 2 3's. So I'm going to bring that plus sign down. Then the 3, and then I have a leftover 3 inside. So this is what I was talking about up here. Usually they'll all end up being the same, but not always. I can combine these two, but I will not be able to combine this one because the radicand is not the same. So the number inside the radical also has to be the same. So the only thing that I can do is combine these two. So what is 3 plus 2? So it ends up being 5 square root of 5 because I don't actually do anything with the radicand plus 3 square roots of 3. That would be your answer. But I cannot combine these two because they do not have the same radical. or radican, sorry. Let's look at another one. Cube root of 9x minus cube root of 72x. Even though it's a cube root, the process is still the same. What two things multiply to 9? 3 and 3. But I can't break 3 down any further. So how many numbers do I need to make a set? 3 this time. So I don't have enough numbers to do that. So that means I cannot write this any further. So therefore, it stays the cube root of 9x. Since 9 only broke down into 2 of the same number, I cannot make it go any further. And then, of course, the x doesn't have at least 3 in there to be able to pull out. All right, but let's look at 72. How does 72 break down? Was 36 break down? Oh, I was going 66, but 2 and 18 would be good too. And then what does 6 break down into? Good, and so is this one. And then yours would have been 2 and 9, and then 3 and 3. But regardless, we would have all gotten 3 2s and 2 3s. Because which ones can I group? The 2s, because I have 3 of them. And then I still have this leftover 3 here and this leftover 3 here. So whoa, I just want to move you. I really thought this was going to be an easier task. Okay. Yes. Sorry. Got distracted. Yeah, so I would be able to take 1, 2 out, and then I have 2 3s left over. But what do I do with multiple leftovers? That's a 36. You good? So what do I do with these multiple leftovers of 3s? I times them. So 3 times 3 ends up being 9. Couldn't do anything with the x. So in this situation, the index and the radicand are both the same. What imaginary numbers over here that I'm going to combine? A 1. So what's 1 minus 2? -1, but do we write the 1? No. So in this case, the what your homework's going to be looking for is negative cube root of 9x. Are we good there? Let's do a few more before we get into multiplication. Hopefully you're finding them to be useful. Yes, that's what I keep telling myself as well. Hey, I gotta do a different test tonight, but I'll come back to y'all tomorrow. That's my goal. I gotta prioritize. All right, I'm gonna let y'all try this one. Correct. Correct. That's right. No, 'cause the when you type it, well, it depends. If you type it in with the radical, well, y'all's calculator, if y'all type it with the radical, the answer will come out with a decimal. And what the homework wants is with the radical. For you, your calculator will shoot out the correct answer. So sorry. Fine. No. Sorry. That's my immaturity. You said 6, 7, and I deal with high school kids all day. Um, so so this would be 6 square root of 7. But what you would have to do since they're all the same is just do the operations outside. Correct. Oh, I got you. Oh, you're talking about the answer. I got you. Oh, yeah, because that's 12 minus 6. Yeah. 6 square root of 7. Perfect. Yes. Gotcha. Gotcha. No, you're good. You're good. Yeah. Go ahead. So since all the square roots and radicals were exactly the same, I can just combine the outside. So 4 minus 6 is -2, and then -2 plus 8 is 6. And then the radical stays the same. So try this one. 8 square root of x minus 5 square root of 3 minus 2 square root of 3 minus 6 square root of x. Can't break down the threes. That's it. So on this one, I can combine 8 square root of x with the minus 6 square root of x since those index and radicals are the same. So 8 minus 6 does give me 2 square root of x. Then I can combine -5 square root of 3 with minus 2 square root of 3 since these index and radicals are the same. And then -5 minus 2 is in fact -7 square root of 3. You can't combine them all, but you can combine some. And that's it. Very good. All right. Now, let's try to bring in multiplication. So in multiplication, you have 3 times or square root of 3 times the square root of 75. Now, to be able to multiply or divide, the only thing that has to be the same is the index. So I can multiply and divide square roots with square roots, cube roots with cube roots, but I cannot multiply a square root with a cube root. That part will be blocked and I cannot do that. So in this case, can I multiply these two square roots? Yes. Then do so. You're going to multiply 3 times 75. Mhm. So that becomes now the square root of 225. Now you can do this one of two ways. If you have the square root of 225 memorized, you can just spit out the answer. If not, break it down with a tree. But two things multiplied by 225. I'll give you a hint. Well, 3 and 75. It's the two things you just multiplied to get to the 225 to begin with. Yeah. It doesn't always give you a perfect number. In this case, it will. I think the answer is 15. But that doesn't always work. So if you get a decimal, then you know you're gonna have to do the factor tree because it's the answers that it wants on the homework is radical, not decimal on this part. So in this case, that's 3 and 75. Then what would 75 break down into? And what would 25 break down to? What can I group up? Very good. And then when I have multiple groups, what do I do with them? So 3 times 5 gives me. So with multiplication and or division, you want to multiply or divide it first, then simplify. So that was actually part A. So with multiplication and division, as long as the index are the same, you actually do the multiplication or division first, then simplify. Versus with addition and subtraction, we had to do all the simplification first before we add and subtract it. So it's just flipped in order of the process. So adding, subtracting, simplify, then add or subtract. Multiplication, division, we'll multiply or divide first, then simplify. So let's look at another one. Oh, this guy? Yeah. So I just grouped up my pairs. So that was a one group of 3 times one group of 5. And that's what gave me 15. Mhm. So then we will see something like this where we have the square root of 13 times the square root of 26 minus the square root of 13. Are they all the same index? Yes. Different radicands, but the little index numbers, they're all square roots. What does this look like to y'all? Distributing. And that's what you're going to do. 13 times 26 with a square root above it, and then 13 times 13 with a square root above it. 338. Okay. Now, when you're trying to simplify this, because now it's back to a subtraction problem, now that you've took care of your multiplication, subtraction tells us we have to simplify first before we can actually subtract. So what does 338 break down to? Perfect. That's an easy go-to. 13 is actually a prime number. What does 26 break down to? 2 and 13. So what can I group? And what am I left over with? All right. What's 169 break into? Again, 13's prime. So then what can I group? Very good. That becomes minus 13. Can I go any further? Why not? Perfect. This one doesn't even have a radical to begin with. So these are not like terms. So I can stop right there. I will say when I took college pre-cal as a student, me and a buddy said the same thing because what I would miss, he would get right. What he would miss, I would get right. I said, man, if we could just combine our two tests, we'd like be a perfect student. I've only seen that the high school days. All right. All right. So what when we did the distributing process, what process did y'all like the best? Did y'all FOIL it or box method it? FOIL either. I think in my opinion, I think folding's a little bit easier in these situations, but box method works just as good. Yeah, 2 square roots of 5 minus 1, and then square root of 5 plus 2. My bad. Mm-hmm. Oh, we can do that. I'll do the box method then. There, and remember the setup. And you can do full too if you're comfortable with that one. All right, so to fill each box, we just have to multiply them. So in this situation, the indexes are the same, so I can multiply them. But one thing I need you to see, and this will make your math go a lot quicker, what did you notice end up happening when we did the square root of 13 times the square root of 13? What did the result end up being? 13. So anytime you multiply two radicals that are exactly the same, you're going to be left with the radicand without a radical. So that's what I was getting at here. So the square root of 5 times the square root of 5 would end up being what? Just 5, because it ends up being the square root of 25, and then we know the square root of 25 is 5. So if you can catch on to that trick right there, then you can see that this will end up just being 5. But then you ask, what do you do with that 2? That 2 has to then be multiplied by that result. So 2 times 5 ends up being 10. So 2 square roots of 5 times the square root of 5 is actually going to be 10. So you multiply the radical first, then whatever coefficients were part of it, then get multiplied to the result of that. So like when I come to this part, 2 square roots of 5 times 2, notice this doesn't have a radical. So the only thing I'm going to be able to multiply are the actual coefficients. So in this case, I do 2 times 2, which is 4, and then square root of 5, because it didn't have a radical to multiply to. So with all that said, so what would negative 1 times square root of 5 be? There we go. Nope, negative 1 square root of 5. You could. In my pre-work, I'm going to write the 1 so that I know that I'm adding or subtracting a 1 to it in my pre-work here. So negative 1 times 2 would give me, very good. So now I'm going to combine like terms. The only thing is this is a little bit different from what we saw with quadratics. This diagonal will be able to combine, and so will this diagonal. So when you're combining like terms, you can combine them crisscross that process here. So for example, what is 10 plus negative 2? 8. Very good. And then what is 4 plus negative 1? 3. And then the square root, good. And then the square root of 5 would remain the square root of 5. Now, the other question I get is, what is the correct order? It doesn't matter. If you would have done this first, that would have been the same answer. So, whichever one. And I say that because when we get to complex numbers, that will matter. But for this, it does not. I don't see a difference. Yes. You cannot add the 3 and the 8 because this one's attached to a radical and this one does not have a radical. So therefore, they are not the same. All right, so let's look at the square root of 3z minus the square root of 5 times the square root of 3z plus the square root of 5. I'm going to give you a little time to attempt this one, either using full or the box method, whatever you're comfortable with. Let's see what you come up with. Oh, it is. Yeah, sorry. So that sign's going to be attached to that, so it came back. Let me space it out a little bit more. Yeah, it looked like it was attached to the square root. I gotcha. So we're going to start with this part here. So the square root of 3z times the square root of 3z, they're exactly the same. So that means that the square root would just go away and my answer would just be 3z. Okay, I'll let y'all continue. So technically it is the square root of 9z squared, but then you would have to simplify that and the square root of 9 is 3 and the square root of z squared is z. So then it'd go right back to 3c. So you could do that process, but then you're just having an extra step. The goal is to see, hey, they're both the exact same. So it's just a 3, or it's whatever the radicand is. Now, when we get to ones like this, where we have the square root of 3z and square root of 5, they're not the same, so I need to go straight into multiplying. So what is 3z times 5? That's it. And the square root's still there. On the next one, it would be, well, depending on where you put your negative. I put mine on the bottom left, but if you put yours on the top right, that would be the situation. So this case, yeah, so mine wasn't negative, but this next one would be negative square root of 15z. So depending on where you put your negative, we would still, when we combine like terms, we'll still combine it where they would cancel each other out. Yeah, would be, that's it. The square root would go away and it's just a 5, but then because of that negative, it does make it a negative 5. Now, when we go to combine like terms, what do we notice with this negative square root of 15z and the square root of 15z? They cancel each other out. So I'm left with only 3z minus 5. Correct. One, yep, because one has a z and one does not. Mm-hmm. Correct. Correct. You could if you want. If you have to, I'm good with that. Square root of 5 times square root of 5 is the square root of 25, but we now know the square root of 25 is just 5. So if you have to do the multiplication of it first, do it and then simplify. But you'll do this enough times, well, eventually you'll be like, oh, it's just going to be this, and you're going to start spitting that out. But until you get comfortable, I'm good with you just multiplying it out until you see it. All right, let's do another one. So you're gonna have one that looks like this, and it's gonna look misconceiving here. Students will typically miss this one. because what students want to do is take this square and just distribute it. That is not the case here. When you have a binomial squared, that means you have two of them. And it's just a shorter way to say the same thing we were just doing in the last two problems, where now we need to FOIL this out. So I'll give you an opportunity to try it. Actually, I don't know. Let's check. I said, I don't know. Let's check. 2 times 2 would be 4. 2 times negative square root of 5x plus 1. What do you think that would be? Not quite. Since this is not in a radical, I can't actually multiply it inside. So it stays on the outside. So it becomes like this. All right, so I'll let you keep going. This one here. Yes, those two negatives would be positive. And then what would, uh-huh. So you're multiplying these two, right? Remember, they're exactly the same. So if they're exactly the same, the radical just goes away and you're just left with what's inside. So no matter how complicated it starts looking inside, as long as it's the same, I can just get rid of all of it. Correct. As long as what's inside is the same. Correct. Because that could not be multiplied in because it was not in a radical. So now how would I combine like terms? And that would give you what? What would that give you? Good. So negative 4 square root of 5x plus 1. The radical will not change. Now what? Okay. So what is 4 plus 5x plus 1? Remember, you're adding. What can I combine out of these? Just the 4 and the 1. The 5x, there's not another x over here, so it would stay 5x. And then I can combine the 4 and the 1, which would just be 5. Yeah. I will say that's probably the one of the most complicated ones you'll see on the homework. Yeah. Get that box written out, get your stuff around it, and then if they're not in a radical, you can multiply it away. If they're in a radical, you can multiply those away. But if they're not exactly the same, we don't do anything with them. You just basically write it out as is. Hmm. It looks complicated, but really it's just a lot of writing because we didn't do no more. Actually, correct. If they're the exact same, I did get no more radical symbol. All right, let's try some more. I'm not ready to move on quite yet. Yes. Hmm? Here when I combine like terms, since they're both negative, it became a negative 4. So I looked at this as, yes, it says the square root of 5x plus 1, but if you pretend that just says like a dollar, if I'm down $2 and down $2, now I'm down $4. But instead of a dollar symbol, our symbol looks like this. So I'm going to let you try this one. 4 square root of 5 parentheses square root of 6 minus square root of 5. I wouldn't, because it's only a monomial. I would just fold it, in my opinion. I box method when it's two binomials, but it doesn't matter. You can still box method this one. Just looks weird. Mm-hmm. Okay, hold on. You're multiplying. When we're multiplying, the only thing that has to be the same is the index. The radicands don't have to be the same. So if I'm multiplying, I would do 5 times 6. I would actually multiply the inside radicals. So the 4 is not in a radical, so that would just come down. But then I would do 5 times 6, which is 30. So that becomes the square root of 30. And then do the next one. Okay. That becomes square root of 25. Correct. I'm missing something. Very good, because what do we know the 5 and the 5 is going to become? It's going to be a 5. Again, you either see it or you don't. But either way, you would have simplified and got to the 5 anyways. But what operations right here? That subtraction sign still needs to come right here. Very good. And we would get 20. You do need to see if you can simplify 30. But if you see, 30 will break down into 15 and 2. And then 15 would break down into 3 and 5. None of them are the same numbers. So this doesn't go any further. So it stays. Oh, I give myself enough room here. So it'd stay 4 square root of 30. But you do want to check to see if it can be simplified. Try this next one. And this next one, you can use box method. Square root of s minus 7 times 9 plus square root of s. S not 5, sorry. S is not 5s. How to combine it? Yeah, that's pretty good though. If you can fill the box, that's actually the hard part. Combining like terms, we can get through that. Perfect. No, it's S's. S is not 5s. Oh, even though that one does definitely look like a 5. Hold on, let's change that. All right, what was that? Sorry, what was this one? Oh, for the last one here? Oh, for the next one here. Perfect. I got you. I can follow. Positive or negative. Okay. Okay. So then this part, you don't know what to do. Okay. That's easy. I can do that. I'll be there. So the goal is the combine the diagonals. It doesn't matter which one you do first. We can combine the square root of s's, or we can combine these. Which ones would you like? It doesn't matter. All right. So if I go this route, can I combine s and negative 63? No, so I have to write it as s minus 63. But on the next diagonal, can I combine the square root of s's? They will stay square root of s, yes. But can I still combine them? Yes. Since the radical, the index and the radicand are the same, I can add those coefficients. Correct. Yeah, the diagonals here, you're adding. Yeah, every time we're adding diagonally. So in this case, what's 9 plus negative 7? 2. Yeah, you can always change it to an x as well. All right, on the last part of your homework, it actually gets really easy because they just want you to type it in the calculator and give the decimal answer. So what I need to do on this last part is just make sure y'all can type it in correctly in y'all's calculator and get a decimal. Oh, yes, sir. Oh, you're good. You're good. It does not. It does not. That's right. And that the same answer. It's the same thing. It's saying the same thing as like what's 2 plus 3? It's 5, right? Well, what's 3 plus 2? It's still 5. So it doesn't matter the order, you're still adding them all up. If you knew what S was, then you could plug it in and then you would calculate the same answer. And regardless of the combination that you have it would give you the same answer regardless, whatever that answer might be. All right, so let's see if you can type this into the calculator correctly. Remember, the question's going to ask you to give it the decimal to the fourth place. So 4 decimals. I got you. I think I still remember. 4 plus 5 square root of 2. Does not want you to simplify. It just wants you to evaluate. I will call her back during break. There it is. So 11.0711. Mm-hmm. Plus 5. Your square root, I think, again, was second x squared button, something like that. Now for you, if you typed it and you hit enter, it just came back the same, right? Or did it give you a decimal? It just gave you the same thing you just typed. I'll come to you. I'll come to you. Oh, square root. So it's going to be that little icon right there. So shift and then that. Here we go. Correct. S the D button. Yeah. There it is. Good. And then when you're working it out and it's wanting you to go back and give the actual radical, you just hit that button again and it converts it back to whatever you're. All right. Try this last one and then we will take a little break. So I got to take that call here in a second. Square root of 8. I don't know why it's so big. Minus 1 times square root of 8 plus 1. Correct. If it's in parentheses, type it like you see it. Yeah, that's a good reminder. Yeah, once you get done typing what you want in the radical, right key it over to get out of the radical, and then you can keep on typing. Hey, the fact that you still remember that's really good. Seven on the dot. 7 on the dot. So make sure you are getting this answer right here. Yes. Most y'all's calculator should recognize that means multiplication. I know with the newer versions with the Inspire, we sometimes have to put a multiplication sign between a number and a parentheses because the calculator doesn't recognize that means multiplication, which is crazy. But your old school ones, or what I call old school, what I grew up with, they understand that means multiplication. I got you. Oh, see how that square root is continuously going?
Okay.
So what we want to do when you so you type in that first one, that 8, and then you want to arrow out of the square root. Then you do your -1. If you don't, what happens is that square root keeps on going, and that's not what we want.
Okay. That's what he was just.
Right. Mhm. All right. So I think what we'll do is we'll take a 5-minute break, and then we'll come back and talk about how to rationalize denominators, which is basically division.